So if you did not watch the first video, I would urge you to watch that if you're having any doubt at all as to how to graph these functions. And in the last video, I ended with one of the keys to success for graphing these functions is understanding the relationship between the a, the h, and the k to the original function. The a, we talked about that. That's a vertical stretch or a compression. It's a vertical change, meaning that the h and the k remain the same, but the a either stretches it vertically so it becomes more narrow, or if it compresses it, if it's between 0 and 1, if absolute value of a is between 0 and 1, then it becomes a little bit wider. So that's not going to change the inflection point. And the inflection point is always going to be your hk. So inflection point is your hk. And so let's take a look. So, and also the a, if it's negative, then the graph would flip over the x-axis. And that's exactly what happens here. So if a is negative, then we still have our hk is 0, 0, and we are decreasing. So this graph is decreasing from negative infinity to infinity. And again, we're always going to label the inflection point. We didn't even label it on the first one. So the inflection point is at 0, 0. I said it, but I didn't label it. So that's number 2. Number 3, we see that h is 2, so we take the original graph, started at 0, 0, we move it to the right 2 units, and we don't go up or down because the k is 0. So the inflection point is at 2, 0, 2, 0. You don't even have to write IP for inflection point. For number 4, we can see we move the graph of the original function. It's cubic. Move it 4 to the right, and then 2 up. And we put our inflection point there. We're going to draw the graph increasing from left to right. And that's it. So we have the inflection point at 4, 2. For number 5, so this sometimes gets a little confusing. The a value is -1, but the k value is 3. So even if the k value, even if there's a number out there, if it's not being multiplied by the parentheses, if it's just sitting out there in space, it's as good as writing it like this: -x plus 2 cubed plus 3. So when we see it like that, our eyes see, oh, okay, the h is -2 and the k is 3. So we go -2 and up 1, 2, 3. So we have our inflection point there because the a is negative. Then we're going to go down from left to right. Didn't leave myself a lot of room here. And we're going to label that inflection point -2, 3. So that's how we work with, that's how we deal with that number that just kind of sitting out there in the beginning here. Normally when we see a number in the beginning, that's our a, but not if it's not attached or being multiplied by the set of parentheses. And then number 6, there's our k value again, and our h value is -3, so we're going to go 3 to the left, 1, 2, 3, and 4 down, 1, 2, 3, 4. So we're going to put our inflection point right there, -4, -3. I messed up. Didn't mean to do that. I meant to say -3 is our h, so -3, -4, and we're going to bring our k value is, our a value is 1, so we're going to go up from left to right, and that comes up. I didn't leave myself a lot of room there, but there it is right there. So the inflection point is -3, -4, and the curve, the graph is increasing from negative infinity to positive infinity. I'll use a new video for the other 6 problems.